Hello and welcome everyone to day 21 of our low-level design course. Today is going to be a very important day as we are going to learn three extremely useful design patterns: the visitor pattern, the iterator pattern, and the momento pattern. These patterns are not just theory, they are used every day in real-world systems, whether it's applying discounts, navigating playlists, or implementing undo features in applications. So let's get ready to dive deep and strengthen our design toolkit even further. Before we get into the patterns, let's first look at today's roadmap. We will start by understanding why these patterns are important, setting the foundation first. Then we will dive individually into the three patterns. First, the visitor pattern, which helps us apply new operations to objects without modifying their structure. Next, the iterator pattern, which gives us a way to traverse data collections without exposing how they are implemented internally. And finally, the Memento pattern, which helps us capture and restore object states, a must-have for features like undo. After covering each, we will also do a quick comparison, followed by a mini exercise to apply what we have learned, and finally we will summarize everything. So why do we need these patterns in the first place? Let's think practically. Suppose we have an application with hundreds of product types and tomorrow we want to add a new pricing strategy. Do we want to modify every product class? That's probably not. Here's where the visitor pattern saves us, allowing us to apply operations externally. Similarly, when you are scrolling through a Spotify playlist, you don't really care how songs are stored. You just want a smooth experience of moving from one song to the next. That's where the iterator pattern becomes critical. And what about undo and redo in applications like Word? Imagine writing 20 pages and then wanting to roll back 5 edits. We need a way to save checkpoints, and that's exactly what the Memento pattern gives us. Each of these patterns addresses real engineering problems, not just academic ones. Let's start with the first pattern, the visitor pattern. At its core, the visitor pattern is about separating an algorithm from the object structure it operates on. Imagine you have a set of different objects, say various types of products, electronics, groceries, and so on. You want to apply operations on these objects like calculating discounts or taxes. Instead of modifying every class whenever a new operation is needed, you externalize the operation to a new visitor class. This follows the open-closed principle. Our objects are open for extension, meaning we can add new operations easily, but closed for modification, meaning we don't touch existing code, thereby avoiding breaking things. This pattern shines especially when the structure of objects remains stable, but the operations keep evolving over time. Let's bring this closer to reality with an example. Think of an e-commerce platform like Amazon. You have multiple product types: electronics, groceries, clothing, furniture. Each category might have different tax rules. Electronics might have 18% tax, groceries might have 5%. Now, should each product class know how to calculate its tax? Ideally, no. Instead, we create a text visitor class that knows how to visit each product and calculate the approximate tax. This way, if tomorrow a new tax rule is introduced, say COVID surcharge, we simply add it to the visitor without modifying the product classes at all. Here's what the code structure looks like. We define an interface for visitor where each method handles a different product type. Each product class, like electronics and groceries, implements an accept method. When we call accept, the visitor gets a chance to operate to the product without changing the product's own code. This makes the system very flexible and future-proof. Now the important question: when should you use the visitor pattern? First, when new operations need to be added frequently. Second, when the object structure itself is relatively stable. And third, when you want to comply with the open-closed principle by keeping your classes unchanged and externalizing new behaviors. But remember, if your object structure changes frequently, the visitor pattern might add complexity, so use it wisely. Next up is the iterator pattern. The goal of this pattern is simple but powerful. It allows to access elements of a collection one by one without knowing how that collection is implemented internally. You can think of it like providing a common remote control to navigate through different collections, whether it's an array, a linked list, or even a tree structure. Let's again relate it to real life. Imagine you are using a Spotify playlist. When you hit next or previous, do you care how Spotify stores your songs? Absolutely not. Behind the scenes, it could be a dynamic array, a linked list, or something entirely custom, but you as a user interact through a simple interface. Play next song, play previous song, shuffle songs, and so on. That's exactly the beauty the iterator pattern provides in software design to a clean way to move through data. Here's how we do it technically. We define an interface called iterator with two methods, hasNext to check if there are more elements and next to fetch the next item. Then any collection like a song collection can provide its own implementation of iterator. This way the user can navigate through the songs without worrying about whether it's stored in a list, a queue, or anything else. You should use the iterator pattern when you want to decouple the way a collection is stored from how it is traversed. You expect multiple types of collections and still want a unified way to access them, or you want to allow multiple simultaneous traversals like forward and backward on the same dataset. Iterator makes collections flexible and extensible. Now let's move to our third pattern for today, the Memento pattern. And this one is a favorite for applications needing undo or rollback functionalities. The Memento pattern allows you to capture an object's internal state, store it outside, and restore it later without violating encapsulation. The key here is the object that saves the state, originator, the object that stores the state, Memento, and the object that manages saving and restoring, caretaker. Let's look at some real-world examples, undo and redo in Microsoft Word. Every time you make a change, Word captures a snapshot of the document. When you hit undo, Word restores a previous snapshot from history. In gaming, saving checkpoints is another brilliant example. Games like Call of Duty or Zelda allow players to save their progress, so if they fail, they don't start from the beginning but resume from a checkpoint. Both of these functionalities depend heavily on the principles of the Memento pattern. Technically, here's how it looks. We create a text editor with methods like setText to edit and methods like save and restore to create and apply snapshots. The Memento object acts like a hidden snapshot, preserving previous states without exposing or tampering the internal workings of the text editor. This pattern ensures separation of concerns, making the system safe and clean. Use the Memento pattern when you need undo or redo features. You want to checkpoint an object's state, or you want to implement state recovery after failures without breaking encapsulation. It's highly useful for text editors, gaming systems, and even financial applications where rolling back transactions safely is critical. Now let's bring it all together. Visitor pattern, use it to add new operations without modifying objects. Iterator pattern, use it to traverse collections without worrying about their internal structure. Memento pattern, use it to save and restore object states cleanly and safely. Each pattern addresses different problems, but together they make your systems more flexible, resilient, and easy to extend. Time for a quick challenge. Think of a drawing app where a user can create shapes, circles, rectangles, lines. Now implement undo functionality. How would you do that? Use the Memento pattern. Each time a user draws, save a snapshot of the canvas. When they press undo, restore the previous snapshot. Give it a try after the session. Today we covered how the visitor pattern lets us add behavior externally, how the iterator pattern simplifies traversal, and how the Memento pattern provides powerful state recovery mechanism. Each of these patterns bring a new level of power and control to your low-level designs. Now it's your time for your questions. Feel free to ask about where and when to use these patterns. Share examples you can think of or clarify any doubts you have about today's session. That's it for today's session. In our next session, we will continue expanding our design skills with the template method and state prop patterns. Thank you so much for your attention and keep practicing. Great designers are made through real-world applications.